What if I told you that right now, as you're watching this video, your brain is performing thousands of learning processes without you even realizing it? You're learning to ignore the hum of your air conditioner, the feel of your clothes against your skin, and countless other stimuli around you. At the same time, you might be forming new associations between ideas, sounds, and images. This isn't magic. It's learning, and it's happening every single second of your life. Learning is far more than memorizing facts for a test or mastering a new skill. It's any relatively permanent change in behavior or knowledge that results from experience. Your brain is constantly adapting, filtering, and responding to the world around you through sophisticated mechanisms that have evolved over millions of years. Habituation. Learning to tune out. Let's start with habituation, perhaps the simplest yet most crucial form of learning. Habituation occurs when you gradually stop responding to a stimulus that's repeated over and over again. Think about when you first moved into a new home near a busy street. Those car sounds probably kept you awake for nights. But after a few weeks, you stopped noticing them entirely. Your brain learned that these sounds weren't threatening or important, so it filtered them out. This process isn't just convenient. The ticking of clocks, the texture of your clothing, the background noise of ventilation systems, all of these would demand your attention constantly, making it impossible to focus on what actually matters. For a psychology major, habituation is more than theory. Picture running an experiment where a light flashes on the wall. The first time, your participant reacts. The 10th time, nothing. They've habituated, and as a psych student, you get to see how quickly the brain adapts. For a nursing student, habituation shows up in the hospital. During your first clinical shift, the constant beeping of heart monitors and IV pumps is overwhelming. But after a few weeks, those sounds fade into the background. What matters now isn't the steady beep, but the sudden change. An alarm signaling something urgent. For an art or design student, habituation explains why you no longer notice how cluttered your studio has become. Each sketch, paint tube, and coffee cup added slowly over time, until the mess disappears into the background of your awareness. Then a friend visits and says, "Wow, this place is packed." They aren't habituated like you are, so they see it clearly. Habituation happens at the neural level through a fascinating process. When a stimulus first appears, your neurons fire vigorously, sending strong signals throughout your nervous system. But with repeated exposure, these neural pathways become less responsive. The synaptic connections literally weaken, reducing the strength of the signal. It's like a well-traveled path in the forest. The more people walk on it, the more worn and less noticeable it becomes. And habituation isn't permanent. If that stimulus disappears for a while and then returns, your brain will notice it again. This is called dishabituation. Parents of newborns know this well. They become habituated to their baby's normal crying patterns, but when the cry changes pitch or intensity, they immediately notice. Their brains have learned to filter out the familiar while remaining alert to the novel. Classical conditioning. Learning to link. Now, let's explore classical conditioning, a more complex form of learning that creates powerful associations between different stimuli. This type of learning was first systematically studied by Ivan Pavlov, a Russian physiologist who made one of psychology's most famous discoveries almost by accident. Pavlov was studying digestion in dogs, measuring their saliva production when they ate. But he noticed something peculiar. The dogs began salivating before they even saw food. They would drool when they heard the footsteps of the laboratory assistant bringing their meals. This observation led to groundbreaking experiments that revealed how our brains form associations between previously unrelated events. In classical conditioning, a neutral stimulus becomes associated with a meaningful stimulus through repeated pairing. Pavlov demonstrated this by ringing a bell every time he fed his dogs. Initially, the bell meant nothing to the dogs. It was a neutral stimulus. But after many pairings of bell and food, something remarkable happened. The dogs began salivating just from hearing the bell, even when no food was present. The food was what we call an unconditioned stimulus. It naturally triggered salivation without any learning required. The salivation in response to food was an unconditioned response, an automatic, biological reaction. But through conditioning, the bell became a conditioned stimulus that could trigger a conditioned response. Salivation in the absence of food. This process happens in humans constantly, often without our awareness. Think about how certain songs can instantly transport you back to specific memories and emotions. The music has become a conditioned stimulus associated with those experiences. Or consider how the smell of your favorite restaurant can make your mouth water before you've even seen the menu. Your brain has learned to associate that aroma with delicious food. For a psychology major, classical conditioning comes alive in experiments like John Watson's Little Albert. A baby who wasn't afraid of a white rat learned to fear it after it was paired with a loud, frightening noise. Suddenly, the once neutral rat became a trigger for fear. A vivid example of how phobias can be learned. For a business major, conditioning explains advertising. Imagine working on a marketing campaign. You pair a soft drink with upbeat music, smiling faces, and summer sunshine. Before long, the product itself triggers good feelings, even when no music or sunshine is present. For a biology major, it's the lingering memory of lab chemicals. The sharp smell of formaldehyde instantly brings back the nerves, excitement, and even nausea from their very first dissection. The smell itself isn't scary, but it's linked forever with that moment. For an education major, conditioning is part of classroom life. A teacher might clap twice and reward the class with praise when they quiet down. Over time, just the sound of the claps triggers students to settle, even before the praise comes. The clap has become a conditioned stimulus linked to order. Classical conditioning explains many of our emotional responses too. If you were in a car accident during a thunderstorm, you might develop anxiety whenever you hear thunder, even when you're safely indoors. The sound has become associated with danger through that traumatic experience. Advertisers understand classical conditioning intimately. They pair their products with attractive models, upbeat music, or beautiful scenery. They're trying to create positive associations that will influence your purchasing decisions. When you see their product later, your brain recalls those pleasant associations, making you more likely to buy. Phobias often develop through classical conditioning as well. A child who gets stung by a bee might develop a lifelong fear of all flying insects. The initial pain and fear become associated not just with bees, but with similar-looking creatures. This is called stimulus generalization. The conditioned response spreads to stimuli that resemble the original conditioned stimulus. Interestingly, classical conditioning can also be reversed through a process called extinction. If the conditioned stimulus repeatedly appears without the unconditioned stimulus, the learned association gradually weakens. Pavlov's dogs would eventually stop salivating to the bell if it was never again paired with food. Why these processes matter. Both habituation and classical conditioning demonstrate the incredible adaptability of our nervous systems. They show how we learn to ignore irrelevant information while forming meaningful associations that help us navigate our environment more effectively. These processes operate largely below our conscious awareness, yet they profoundly influence our behaviors, emotions, and perceptions every single day.